Hi, welcome to my workshop video. So this is for question number 3. So this question number 3 is ANOVA one way. In the final exam, I will write there, if this is a question for ANOVA one way, it is ANOVA one way. So please don't calculate any of the statistical analysis. Right, look at the question there. On your screen now is the question 3 of my workshop. This is a long question. It's spanned until 2 pages. Okay, so I'm going to discuss this. I'm going to read this together using a yellow highlighter. So it says here, a team of 5 astronauts left Earth and set to Mars to build the first colony. So the team consists of engineer, a doctor, a strategist, and a launch control vehicle, and another one person which is not named. It doesn't matter. Right, what is their mission? Let's use a red marker. The first objective is to rendezvous with Pathfinder or the robot rover, figure 3A. Okay, so this is the figure there. Right, they want to find this robot. Okay, why do you need to find this robot? Because it is been out of communication since March 2018. Alright, and then they must see this robot or find this robot because it carries vital information of Mars surface condition. Alright, so once they are safely in orbit, they're contacting the Mars Global Surveillance Satellite, and from there they read the pings or the hertz or the return signals obtained from the Pathfinder rover. So these 4 people is going to be working on these 4 sectors, namely sector 1, 2, 3, and 4 respectively. These sectors are the possible last site of Pathfinder. So these 4 people read the pings that comes from the Pathfinder by using the MGS satellite, which is orbiting over Mars. So here it is ANOVA one way because it only have one factor, which is the location of the Pathfinder robot rover. So they are given in hertz. As you can see here, we have 4 levels: 1, 2, 3, 4. Even though the table are not, are not in one specific table, I separate them into 4 like this. They are still ANOVA one way because they are one factor, which is the ping, which is the location of the Pathfinder robot, and there are 4 people who are reading this data, and there are 5 repetition. Therefore, we have, you see, 1, 2, 3, 4, 5 repetition per people. Right. So your repetition for ANOVA one way is given by n, which is 5. And small a for level is 4. 4 level, 5 repetition. Okay, so let's do the answer. Again, this answer is written in Excel file. So you can find the equations. Let me go to my Safari or my browser. To find this equations, please refer to page number 2 on the formula sheet. Right, page number 2, analysis of variance table. I also print it out, so it is on page number 2, as you can see here. Okay, it's clear there. Okay, so first is you must find the total. We call this as grand total. You must also find the average for each of the factors, and you must also find total for each of the sectors. Right. So we must find total for all levels. You must find average for all levels, and from there you can calculate the grand total. So this one is SS total calculation, is SST. Where can you find SST? Which is, if you go to the formula sheet, it is total SST. So I have it here as well. This one, I enlarge it, SST, or this one, you can see here, total sum of square for total SST. Right? So the calculation here, of course, it is on Excel. So what you need to do is, for all of these data there, you need to square them one by one and plus them, and you get the total of this number. After SS total, right, this number, SST, you have to find SS level. SS level also given in this, which is SS treatment, right, SS treatment. So if you go on your screen there, SS treatment is also SS level, right? To find this SS level, let's see, right, so 1 over n means 1 over repetition, and for each of the total for each level you square them and minus the grand total squared divided by the grand number of runs. So it is 5 times 12, which is 20. So you can see here, use this equation, right, this equation there, SS treatment, and try to find my answer SS level, and from there SST minus SS level, you get SS error, which is this, and all must be in positive value, all of them, SST, SS level, and S error. So then using MS factor, mean square factor, also available here, there, MS factor there, and the degree of freedom also equation is over there. Okay, let me go to this. So the degree of freedom is given by these 3 and the mean square as well, right? If you have all the SST, SSE, and all the degree of freedom, you can calculate the F0, where F0 is our final calculation. If you do this, you pass half of it, right? You pass. After that, since I didn't announce what is our alpha, you need to use all alpha. Okay, and you can see the one that we get from the table is 3.49, 5.95, 10.8. So this comes from the table. Let's go for this one. 5%, 3 degree of freedom of a level, and 12 degrees. So it's not 12, it's 16. 16, yeah? 16. So most probably these are wrong. So let's go and find this. F 5, 3, and 16. So let's go to our table. Here, 5, you have to go to this one. Okay, so above there, V1 is your degree of freedom of level, which is 3. Wait, is it 3? 3, and V2, the column there, is 12. So 3 and 16 is 3.24. So this is 3.24. How about 1%? Let's go to 1%. This is 1%, 3 and 16, 5 to 9. And the last one, 1%, 0.1%, 16, 906. Alright, so all in all, 66 compared to these numbers, they are still bigger. So therefore, H1 is accepted. So I'm going to use a blue pen. H1 is accepted. So from there, you can choose 5%, 1%, or 0.1%. For me, I'll choose over here 0.1% because the sectors are too big. Mars is too big. So I try to open up the distribution, this one, the distribution graph, as much as I can, so I can allow more data to come in. But some of you will accept 5%, so you must justify that. Here I justify that I accept H1 with 0.1 because I need to open it as big as I can, and I can find where is the location for the rover. Since H1 is accepted, you need to calculate the effect estimates, where all the average, right here is average for each of the levels, you minus with the grand average, which you have calculated here. Right, from there you get your you get your results. So here you have a negative value and these two are positive. Since we are looking the location of the pathfinder, you must find the positive value because the negative value will say it's not there. Right, so the biggest number is sector 4 at 89.25 positive. Therefore, we believe selected for the most possible position for pathfinder location.